Hello, welcome back. We're learning how to write ionic compounds and ionic formulas today. Before we start learning ionic formulas and compounds, we'll review what ionic compounds are. Okay, it is between a metal and a non-metal. So if you look back, metal is on the left side of your staircase here, on the left side of the metalloid. So your metals are over here, except for hydrogen. That is a non-metal. Okay, hydrogen belongs over here with the non-metals. So keep that in mind. You will need to know that because ionic bonds are between metal and nonmetals. Before we start, at this point we already know the number of valence electrons, right? We know the number of valence electron. The first column is 1 valence electron, 2 valence electrons, 3 valence electron, 13, 4, 5, 6, 7, and then 8 going down, except for helium, only 2. Yes. So at this point we already know that. So the valence electron affects how they bond, right? Whether they gain or lose or share electrons. And so ionic bonds, one will transfer, one will give, and one will take. So the one with 3 or less will give away. So you have to know these things called their oxidation numbers, which we have already done. So group 1 will always give away 1, so it's going to be positive 1. The charge is always going to be 1 plus. Group 2 is always going to give 2, so it's going to be 2 plus. Group 3 is going to be give away 3, so it's 3 plus. It gets a little tricky as we get to group 5, 6, 7 here, because from 5 it's going to start to gain 3, so this group is going to be actually negative 3 minus. Oxygen is going to gain 2, so it's going to be negative 2. Sorry, it's a little messy here. And then group 17 is going to be negative 1, right, because it's going to gain 1 more. So the valence electron tells you if it's going to gain or lose. So know that. It's going to help you write ionic formulas. Remember, group 1, 1. Group 2, 2. Group 13, 3 plus. Group 15, 3 minus. Group 16, 2 minus. Group 17, negative 1. And you'll remember that. Okay. A little tricky with group 14 here. Group 14, we have 2 here, down here. That's metal and non-metal. They're considered transition metals. They could have plus 2 or plus 4. So it's a little confusing. 4 plus, I'm sorry, should be the other way around. But let me see. Okay. So yeah, so tin and lead could be plus 2 or plus 4. We'll get to that another point. Okay. But know that. Okay. So you have 2 worksheets here. Let's see which one we do first. Page 55. You picked up 2 papers. We'll do page 54 first. Write the formulas. Okay. So the formulas here is fairly easy. The whole idea about ionic compound is to balance out these charges. Okay? To balance out these charges so the whole overall is 0. Alright? So follow along. We'll do a lot of these together. Okay, NaCl. Na is plus 1. Remember, it's in the first column, that's why it's got a plus 1. Right? Na, everybody in this first column has plus 1. NaLik, all that is the whole column is plus 1. So Na is plus 1. Cl on group 17, it is minus 1. Plus 1 and minus 1. So the idea is the charge needs to be 0. So total charge equals 0. Right? So total charge equals 0 because you just have to balance out. Okay? So you check this out. Plus 1 and minus 1. Do they cancel each other out? Yes. Plus 1 and minus 1 equals 0. So then the formula is just 1 Na and 1 Cl. Oops, sorry. 1 Na and 1 Cl. Like that. Number 2 here. Look at Ba. Ba is plus 2 and F is minus 1. So how many F's do we need to balance out? So we basically need Ba is 2 plus, right? So we need 1 F minus and then another F minus. But we need 2 F's. So it's Ba F 2. We need 2 F's to cancel out with the Ba. Does that make sense? Because 2 times negative 1 here, that gives you a negative 2, and a positive 2. Ba already is positive 2. And you might ask, why is Ba positive 2? Look, the chart we did earlier, Ba is on the second column. It's going to be positive 2. Alright? Write these numbers, the plus 1, plus 2, all that on your periodic table too. If you have one. If you need one, when I come back, I'll give you a new periodic table. Alright? So Ks right here, K plus Okay, that plus sign, the simple plus sign means it's 1. S is -2. So we have to match. How many K's do we need to match with the S2? We need 2 of them, right? So K, 2, S. Okay, so up to this point, I'm showing you how to balance the charges. But really, there's an easier way to do this. Okay, first you check here, Li and Br, +1 and -1. Those are nice. Why? Because you just write Li and Br, just 1 Li, 1 Br. Okay, another way I want to show you this little trick here. Always going to work. If you look at the charges, here's +3, here's -1. All right. So if they're different, first of all, check if they're different. Then you cross them. You cross just the number. So it's like, okay, I'm gonna write it bigger. Okay, Al 3 plus and I -1. So the numbers are different, right? Just take the number and cross it over, drop it, cross and drop it. So it's Al I 3. Okay. If it's a -1, you don't need to cross the 1. So this is -1, you don't need to cross the 1. Because the 1 is understood, just like in algebra. If you write 1x, you don't write 1x. You just write x. Okay. So number 6 here, you have +2 and -2. So they cancel each other out, so you don't need to cross them. Just Zn, 1Zn, 1S. If you cross them, you'll get Zn 2S2 if you cross them, right? You just cross the number. If you do that, you have to simplify too. You have to simplify, so that's the 1 to 1. And if it's 1 to 1, you don't need to write it. Okay? Formulas are pretty easy to write when you know you have the oxidation, you have the charges correctly. So O here is -2, is 2. So just bring the number down. Bring that 2 down across the AG. So it's AG to O. Okay? So pause the video, finish finish the rest. I've already done 7 with you. Pause the video, finish 7, and then continue to the next one. All right? This should take you about 10 minutes to do. So 10 minutes later, now you get to write the formula names. It's pretty basic here. It's just one step. Name the metal. Name the metal. Just normal name. And so it says here, name the following ionic compound using Roman numerals. So when to use Roman numerals? So if the metal is transition metal. So you have to check that. Is that metal a transition metal? Remember, transition metals are here. Right? So you make note. I'm going to give you a couple hints here. Transition metals. It's a couple one. Like copper is transition. Like number 4 is transition metal. You need to use Roman numeral. Number 5, you need to use Roman numeral. Iron, you need to use Roman numeral. Because iron, copper, they're all in transition metal in the middle here. Okay. One of this is silver here is in the transition metal, but silver is always +1. So you don't need it. Silver, you don't need. Silver's Ag is always +1, so you don't need. It's only got 1 charge, so you don't need transition metal for Roman numerals, right? But if you do, you write Roman numerals. I won't count wrong either. By Roman numerals, chromium, transition metal. So when we put an asterisk right next to it, a star right next to transition metals, chromium there. 16 here. You see, it's weirdly written. And 19 and 20. Okay. Oops. Stars are looking very starry. So you should have. These are your transition metal ones, and I'll show you examples of how to write these as well. All right. First, name the metal, the non-metal. So the metal which is the cation, right? It's the positive, the cation. Name the metal which is the cation. If it has a transition metal, you have to use the Roman numerals. And the Roman numeral is basically the charge. This is for the Roman numerals. 1 it's for 1. 2 is I like that. 3 is 3 like this. 4 is IV. It only goes up to 4 really. So this is to show the oxidation number, which is the charge. Okay. So I'll show you a couple. So name the metal. The second one too is change the ending to IDE of the second one. Change the second element to IDE. Okay. And a couple things. Chlorine will change to chloride, for example. Change the ending to IDE. Oxygen will become oxide, okay? Not oxygide. Some people actually write like that and things like that. Okay? Same thing with nitrogen. Is that nitrogide is just nitride. All right, it's a little weird. There's no particular rule. Bromine will become bromide. Chlorine will become chloride. Sulfur will become sulfide. Okay. Phosphorus. Oh, there's no E in sulfur. Phosphorus equals phosphide. All right. And what else? Chlorine. Iodine becomes iodide. Yeah, I basically hit most of the common ones here. So we named this, the first one, we named barium, Ba. Look at that element on the periodic table, barium. Then chlorine becomes chloride. Chloride. There you go. Okay. Sodium. Next one. You can do this one, right? Na is sodium. Fluorine becomes fluoride. All right. Number 3. Ag, silver. It's a transition metal, but we don't need to write Roman numeral for silver because it's always 1. It's oxide. Okay. Okay, when it gets to number 4, when it gets to transition metal, it's a little more complicated because you have to find out the charge of that thing. Right? CuBr, Br, remember, Br is on group 17, it's -1. Right? Br group 17 is -1. You have to know the charge of Cu to balance out, so we know that Cu has to be +1, the opposite. So then when we write the name, we write copper, then we have to put 1 in the Roman numeral, copper 1, and the ending is still the same, bromide. Okay? Copper 1 bromide. The difference between that, on number 5 here, Br, you see CuBr2 and CuBr1. What's the difference, right? The difference is that tiny little 2 at the bottom here. The 2 tells you that there's 2 bromine minus 1. If there's 2 of them, the total we have is -2, yeah? There's 2 of them. -1 plus -1 is -2. So this copper must be +2 to balance it out. All right? In other words, you can actually recross the number back. If there's numbers here, you just cross it back up. Remember we crossed it down for the formula before? So cross it back up. So it's copper 2 inside parentheses bromide. So the difference is copper 1 and copper 2 bromide. It's 2 different coppers. Okay. So iron here, FeO. Right? Fe is, we don't know, right? Transition metal. Oxygen, but we know oxygen is -2 because look, oxygen, group 16, always -2. Oxygen, sulfur, selenium, -2. So some of them you will remember. You'll do enough, you'll remember, oh, -2, easy. So iron must be +2, so this one is iron 2 oxide. So it has to balance out. Remember, it has to balance out to get to 0, right? +2 and -2 gives you 0. Okay, when there are different numbers like this at the bottom, it's actually easier. You don't have to think about the charges. Cross the charge back up. 2 belongs to oxygen, so 3 belongs to iron. If the numbers are different, you just cross it back up. So this will be iron 3 oxide. All right. So remember, you only need to do the transition metal ones for the star ones. If you don't know how to do it, just name it. Just write like chromium chloride, and I will reteach it to you another time, or get one-on-one with you and show you how to do it again. But go ahead and name it. Name the first metal, change the ending of the second to IDE, and then you can finish the rest of this paper. Have fun, do the best you can, and we'll all be happy with that, right? Have a wonderful day. Bye-bye.